All right, welcome back. If you've followed along up until this point, I really appreciate it because this has been quite the journey that we gone through together, and this application is taking shape. So we have quite a few commands here, and we have just a few to implement before we're gonna call it a day. So hang in there, and in this video, we're going to implement the RM command, which removes an entry out of a directory. So as before, you've gotten used to it already. Create a new command, call this RM, and pass in over a name, which is a string. This will extend command. Okay. And the apply method, of course, I don't have autocomplete here, so override def apply state, which is a state. Yes, alt enter. Yes, import my statements, of course, and this returns a state. And cool. What do we have to do here? Of course, as before, we're going to split this into more manageable pieces. So we are going to do the following. First of all, get working directory. This is going to be pretty easy. Then we need to get its absolute path, the absolute path of this name that we're passing in. So get the absolute path. Then do some checks. Because, for example, we do not want to support rm/, right? You know the infamous command rm-rf/, which who knows what might cause, like nuclear war and stuff, and we do not want to support that. So do some checks for get or find the entry to remove, and update structure, like we do for mkdir. So we got quite a little bit of work. Some of these steps are easier than others, but we're going to tackle them in turn. So getting the working directory is going to be very easy. So val, let's call this wd, which is state.wd because state already contains it. This is pretty simple. Then we need to do the absolute path thing. So absolute path is, well, what do we do? Now, if name is starting with the slash, that means the name is an absolute path, then the absolute path is going to be name itself, but otherwise we need it to append it to the working directory. So we are going to implement a similar logic. So if name starts with directory dot separator, then it's name itself. Otherwise, if the wd, the working directory, is root, remember the problem that we had before, then we need wd path plus name or slash name. Okay. Otherwise, wd dot path plus directory separator plus name. Right, so beginning from working directory's path, then a slash, and then a name. Cool. Doing some checks. In this case, we are going to check absolute path to not be slash. So if directory root or root path equals absolute path, right? We do not want to support this, so we are going to say state.setMessage nuclear war not supported yet, or some other message of your fancy. Okay? Otherwise, it's legal to do or to attempt to do an RM. because we also need to find the entry to remove and then to update the directory structure. And we're going to collapse these last two steps into an auxiliary function that we are going to call, say, dorm. In the same style that we did for other commands as well. So do rm with state, and because we need to pass it, and the absolute path. Okay, and in this do rm function, we are going to attempt to find the entry and update the directory structure. So let's define do rm with state, which is a state, and path, which is a string. This returns a state, and we need to move these steps into this function. Okay, so here's what we're going to do. Find the entry to remove and update structure like we do for mkdir are going to be collapsed into a little bit of a helper function, because it doesn't really make sense to find the entry to remove and then navigate to it and then update structure. We are going to do these things in one go. So let's create some values beforehand and call this little helper function after that. So first of all, we need to prepare the path as a list of string, as you've gotten used to from the other commands. Just split it and pass it on to this little helper function. So let's create a small value which is going to be a tokenized value for path. So let's call this tokens. It's going to be path, which is the absolute path. Then we will substring 1. That means we're going to eliminate the first slash and then split by directory.separator. And then, because this thing is an array, we're going to call toList on it. Okay. And then we're going to create a new root. New root is going to be whatever function we will write after that. So let's call this rm helper or something, which receives the old root, which is state.root, and the absolute path of the thing that I want to remove. Now, we need to check if new root is the same as the old root, because if it is, then this means that the directory structure has not changed. And if it has not changed, then it means that we haven't actually managed to remove anything. And that only happens if the path is invalid or the entry at this path could not be found. So we need to actually check if new root is equal to root. So let's declare the type here, which is directory. And if new root is equal to root, or state.root, then this means we haven't managed to remove anything. So let's return state.setMessage and say path plus colon, in the same Linux fashion, no such file or directory. Otherwise, a new state with the new root and the new working directory, which will be found by navigating from the new root at the old working directory's path. So new root dot find descendant, but the find descendant method takes a list of string. So we probably need to overload this method with a relative path as well. So let's say state.wd.path, so the path of the old working directory, then call this substring 1, and this is the relative path of the old working directory relative to the new root, and we need to overload this little find descendant method that I'm going to do right now. So this find descendant, where are you? Okay, so define find descendant with a relative path which is going to be a string. And this returns a directory. A string with a single n, please. So we're going to leave this unimplemented for now. And we're also going to create this RM helper method, helper function inside. So define RM helper from, and what are we going to do to pass in here? We're going to pass in a current directory, which is a directory. My intuition says this RM helper thing is going to be recursive. Because we're going to update the directory structure in one go. So it makes sense for RM helper to be recursive. And the path is going to be a list of string, because we're going to use the tokens, by the way. So the path here is going to be a list of string. And finally, this will return a directory, because its whole purpose is going to return the new root. So it's going to return a directory because the root is always a directory. Good. This is going to be a little more involved, and let's just put a simple to-do here. Remember to implement find Descendant in directory. Now, what do we have to do here in RM helper? Well, because RM helper is going to be recursive, we're going to start with the edge case, which means if path is empty, then we're going to return current directory, because there's nothing to remove. So the RM command basically failed because we're returning the same instance of the directory. Okay. Otherwise, if path tail is empty, then we're into business, because we don't need to navigate anymore. So we need to remove the entry denoted by path head from the current directory. So we're just going to say current directory dot. We're probably going to need to add a new method called remove entry or something like that. So we're going to give it given the name of the entry that we want to remove, which in our case is going to be path head. Let's create this in directory. So I'm here in the directory class, and I'm going to add the remove entry method, and the entry name that I want to remove is going to be a string, and it's going to return a new directory. And we'll leave this unimplemented for now. We're going to come back to it a little bit later. Okay. So these two cases were pretty easy. All right. So if path is empty, there's nothing to explore. If path tail is empty, there's nothing to explore, but still remove the entry from the current directory. Otherwise, there is more to do. And first of all, we need to find the next directory to navigate to from path head into the current directory. So we're going to declare a next directory to be current directory. So current directory dot. We need to find the entry denoted by path head. But now we have the utility method in there, so we're going to pass in path head. Now, if the next directory here is not a directory, but is a file, so if not next directory is directory, then I'm going to return current directory, because as we said before, returning the same instance of the directory structure means that RM has failed, because we haven't actually removed anything, right? So if not next directory is directory, then we're returning the same instance. Okay, that means a failure for RM. Otherwise, we need to replace the entry with whatever happens after I'm going deeper in the directory structure. So that means I'm going to say current directory dot replace entry, and the entry name is going to be denoted by path head, and the new entry is going to be a new next directory, which I'm going to declare in a second. So let's create a new next directory, which is the result of this same function, rm helper, starting from this guy, which is the next entry that we want to navigate to, and path tail, because we've already used path head. The next directory will need to be converted to a directory, so call the method as directory on it. Okay, now if this rm helper has failed, then the whole rm helper will fail. So if new next directory is equal the old next directory, then it means that this call has failed. So the whole rm helper thing will fail. So just return current directory. Returning current directory, remember, means the rm method, the rm operations will fail. Otherwise, just replace the entry. So I understand that this thing is pretty involved and pretty complex. We're going to go through it again so that you understand what it does a little bit better. Okay, let's run a small, or a couple of small examples. I just deleted this to do because we have two methods to implement, so we're surely not going to forget them both. So let's say, for example, that we are in the root folder and we need to remove the /a folder in the root. Assuming the root folder already has /a, the path /a will be transformed to the list a by this guy, by this expression. So path substring 1 split whatever, this is going to return the list of all the tokens, which in our case is going to be just the token a. Now, if I do rm helper with the root and the path as a list of tokens, this is going to say, is path empty? Then in our case it's not. Then if path tail is empty, which is true, then current directory remove entry path head. Path head is just a, and current directory is root. So assuming that remove entry works well, then this guy will return a new root. New root without the folder a. Again, assuming remove entry works well. Okay? Awesome. Now, let's assume that we want to remove a more complicated example. So say we have /a/b, a nested folder, and we want to remove the b folder. This will get transformed in the list quote A and quote B by the tokens. So this token's value will contain the list A and B. And the rm helper will ask, is path empty? In our case, it's not. Path tail is empty. Well, it's not. And then we need next directory, which is root, or the current directory, dot find entry with path head, which means find me the directory with the name A in the root, which is /a. Now, if not next directory is directory, which is in our case not the case, so we're going to get past this. Otherwise, the new next directory is rm helper with next directory as directory. Remember, next directory is /a. It is a directory, so we can convert it. So we're going to call rm helper here as well. Rm helper asks, is path empty? And in our case, the path is less elements to consider. So we do rm helper with /a and the list composed of b only, because we're doing path tail here. And rm helper asks, is this guy empty? Well, it's not. Is path tail empty? Yes, it is. Then current directory, which is /a, remove entry path head, which is b. So we're going to return a new /a, assuming again that remove entry works well. Back to the bigger rm helper call. We're right over here at line 51. And if new next directory is equal to next directory, remember, next directory is /a, and we're returning a new /a because remove entry we assumed worked well. So in our case, this thing will return false. So new next directory is a new thing and will not be the same instance as next directory. So this guy will not be executed. Instead, the else branch will be executed. So current directory is, in our case, the root folder, because we're at this level, remember. And basically, we replace the name with the name a, or root, dot replace the name a with the new instance that we've just computed, new next directory, new /a, which is a new root. And that'll be the end of the big rm helper call. So I hope this little example gave you a little bit more intuition of why rm helper works well the way that we wrote it. So right now we're in a good position to actually test the rm command because we are pretty much done. So as before, let's add the command, else if rm equals token 0. If we're going to copy this logic, this little piece, so if tokens is less than 2, let's just not copy recklessly. So do cd and rm here, and otherwise new rm with tokens 1, and the rm constant we're going to declare it above. So rm equals the rm string, and that'll be it. Let's run. Compile. Okay, let's create a directory. So we have a directory, and let's try to remove it. And we have an error. And that is because not implemented, because we have forgotten to implement our two methods that we promised we would not forget to implement. Okay, we need to implement these two methods, find descendant and remove entry. Cool. Let's start with find descendant. And this implementation is going to be pretty straightforward because if relative path is empty, then I'm going to return this same instance because it makes total sense, right? If relative path is nothing, then there's no reason for me to return any descendant. Otherwise, I am going to return find descendant with the tokenized path, right? So the other find descendant. So find descendant of relative path, I'm going to tokenize it. So I'm going to split by directory separator to list. Okay, so we are overloading find descendant because it's useful to have this method overloaded. So this is pretty straightforward. Remove entry is going to be almost as straightforward because if the entry name is non-existent, so if not what do we call this? I think we call this has entry. Okay, so if not has entry, entry name, then I am just going to return this, because there's nothing to remove. Remember, removing returns this same instance only if removal fails. Otherwise, I'm going to return new directory with the same parent path, the same name, but different contents. So contents, filter, and the predicate is going to be in the same style as we wrote, for example, here. And for an element x, the predicate has to be that x.name not equals, so not x.name equals entry name. So basically what we're filtering is just the contents whose name is not equal to the entry name that we wanted to remove. Okay, so this should be it. Let's rerun the app again. So let's create a file and just remove it. And ls, and alas, we don't have any files. Good. If we have a file and then remove it, we don't have it anymore. Okay, let's mkdir a and then cd a, and then create another folder, mkdir b, and then cd dot dot. We're in the slash folder, and then just remove a/b. So the A folder is there, but if we navigate to it, there's nothing in the A folder, which is what we wanted. Okay, so RM works as expected, and this, friends, should be enough for this video. If you're following along so far, you're a hero. I'll tell you that. Thank you for following up so far. We only have a few things left. We have appending to files and displaying file contents, which is not going to be all that much to do. The echo is pretty involved in that it receives multiple parameters and multiple operators, but we're going to deal with it in due time. I'm going to close this video, and I hope that you will join in a few minutes. Okay, I'm signing off. I'll see you in the next video.